Hello and welcome back to Chemistry Talk. I'm Hunter and today we'll be discussing the electron configuration laws, the Pauli exclusion principle, the Aufbau principle, and Hund's rule. So the first one to look at is the Pauli exclusion principle, and this states that in an atom or molecule, no two electrons can have the same four electronic quantum numbers. So that is the same thing as saying that they cannot have the same spin. Now, what do I mean by that? When you're drawing a orbital diagram, so let's say we were drawing the orbital diagram for beryllium. We fill up our 1s subshell, and we fill up our 2s subshell. Now, that is the correct way to write it, but the incorrect way to write it, or just one of the incorrect ways to write it, would be this way. Because, in this case, they have the same spin, and they cannot have the same spin. They need to have opposite spins. So that's the incorrect way to write the electron configuration for beryllium, and that is a violation of the Pauli exclusion principle. I believe I have a diagram that shows that exact. Yes, I do. So this is the exact diagram I just drew. That's the incorrect way to write it for beryllium. First, because the two orange ones in the 2s subshell have the same spin. And the correct way is when they have opposite spins. So that is the Pauli exclusion principle. The Aufbau principle says that when writing down an atom's electron configuration, we begin at the lowest energy level and add electrons to the higher energy sublevels until we meet the number of electrons. Now, what can happen is that sometimes before writing the electron configuration, we skip a level by accident, or we double up on a level, and that's not allowed. So let me give you an example of a violation of this. So let's say we were drawing the electron configuration for boron. Boron has 1s2, 2s2, right? Now we need to move into the p subshell. Now in order to move into the p subshell, we have to recognize how many electrons we're going to need. So in boron's case, it is the first one in the p level. That is why it would be just 2p1. Now, if you've watched my previous videos on electron configuration, that should make sense. But if we're going to draw the valence shell diagram, it should look like this. That is the correct way to write it. Now let me give you an example of a violation of the Aufbau principle. So hopefully you recognize what I did wrong here. And what I did wrong is I skipped the 2p orbital. And that's not allowed. So that's a violation of the Aufbau principle. And I believe I have that diagram here. Yet just for a different element. That's just for nitrogen. But that's a violation right there. And our last rule is the Hund's rule. And that states that every orbital in a sublevel is singly occupied before every orbital is doubly occupied. So, what do I mean by this? It's pretty simple. It means that, let's say we were drawing the electron configuration for nitrogen. Let's say we were drawing the electron configuration for nitrogen. We would get our 1s subshell filled, our 2s subshell filled, and our, can't do that, 2p subshell filled. Now it's the third one in, so we're going to have 3 arrows. But some students will make a mistake and draw it this way. They will draw it as so. It's just one way to violate it. Do you see what I did here? If you don't, I double occupied that orbital before singly occupying every orbital. So really I should have spaced it out like that, but I doubly occupied it before spacing it out completely, and that's a violation of Hund's rule, which I believe I have a diagram of right here. Okay, so what I figured we could do now is I have some examples of some other violations, and I figured I could draw some of them and you would tell me which rule is violated. So here's our first one. Okay, I'll let you take a look at that for a second. Okay, so hopefully you can recognize what the mistake is. And the mistake is that we were trying to write the electron configuration for magnesium. But this would be incorrect because we didn't fill up the p subshell. We're missing a spin, and we automatically jumped to the 3s subshell. And that's a violation of the Aufbau. Aufbau principle. Okay, moving along here. Okay, here is our next picture. Okay, so I'll let you take a look at that, see if you can find anything wrong. Okay, so what you should see automatically is that we were going to write the configuration for neon, but we made a mistake, whoops. We made a mistake right here because they have the same spin. And that's not allowed. So this is a violation of the Pauli principle, Pauli exclusion principle. Okay, one more I have, whoops. Okay, so I'll let you take a look at that. Okay, so what you should see is that the P subshell can hold 6. And we've already doubly occupied this first level of the P subshell before singly occupying the whole subshell, or this area. So it should look like that, and then we double up. And that's a violation of Hund's rule. So I hope this helped you to understand the electron configuration laws and rules. Leave a comment below if you have any questions or any requests of videos you'd like